Hi everyone, welcome to Steering Marinas, and in today's video we'll be talking about ECDIS. ECDIS, as you know, stands for Electronic Chart Display and Information Systems, and it has replaced the traditionally used paper charts for navigation in many vessels. The ECDIS was introduced to lighten the workload of the mariners so that they could focus on other important tasks on bridge, such as maintaining a lookout towards collision avoidance. In today's video, we are going to be talking about what is essentially ECDIS and the basis of ECDIS, which is the GIS. GIS, as you probably know, stands for Geographical Information Systems. And GIS is actually, they are computer-based systems which are used to store and manipulate geographical information. GIS is ideally suited to analyze multiple and numerous data sets which are quite diverse in their content. Now, geographic information has been the basic information for navigation, whether it is navigation at land or sea. Now, since early days, maps and charts have been used for displaying the information as analog databases. However, GIS is in effect any computer-based system which displays the geographical information with some intelligence that can be used for an interaction with the user. A GIS is essentially a computer system that manages spatial data. Now, if you don't know what spatial data is, the word geographic implies that the location of the data items are known in terms of the geographic coordinates such as latitude and longitude. So the word information implies that the data in a GIS is organized in such a way that it produces useful knowledge in terms of colored maps and images, or it could be graphics, tables, and also allows you to interact to or respond to interactive queries as asked by the user. So the word system in GIS is made up of several interrelated and linked components with different functions. So the GIS will require a means of data input from maps, aerial photos, satellites, surveys. It will also store the data, retrieve the data, answer to the queries, and the data reporting will be in terms of maps, reports, plans, and all that data will be fed into this computer system, which is the GIS, and it will analyze that data and provide the information required to the user. Now, since the focus of this presentation is on GIS, you have to know a few things about GIS. So GIS are of course computer-based systems that not only store the data but also analyze it to provide useful information to the user. And the GIS is related to the other database applications as well. So the GIS is specially linked to the spatial reference. Now, other databases, they contain location information such as street addresses or zip code, but the GIS databases, they use georeferences as the primary means of storing and accessing information. So as you know, the GPS that you use in the car, that also provides you with location information. But here the GIS, or the Geographic Information System, integrates the technology. Now, other technologies might be used only to analyze aerial photographs and satellite images to create maps. But these capabilities are all offered together within a comprehensive GIS. The GIS also has numerous functions within itself. So the way in which you enter the data or it is stored and analyzed within a GIS must mirror the way information will be used for specific research or decision making. So a GIS essentially is a computer software system with also some supporting hardware. It also manages data pertaining to not only water but also to land and air resources. You can use the GIS to store and retrieve geographic information, as well as analyze stored information or additional parameters derived from stored information. If you think about it, the GIS historically has been used in even people who have been in the military or the armed forces, or to even carry out census, forestry, resource management, etc. Now, as you know, in the military or in the army, it is very important for the armed forces to guide themselves, to know where they are, and then to take the best route possible, which is friendly for them, which in which they will not engage with enemy. So those kind of systems are the military GIS systems, and those are made by integrating it with battle simulation systems. But that is for the use of the military. In this video, I'm going to talk more about it from the point of marine use. How is it used in marine? Now, but before I do that, I must tell you that GIS is an integration, or it integrates computer-aided design such as CAD, data management, computer cartography, and remote sensing, because it uses all these functions to create those interactive images that is user-friendly, that can be used for the user or by the user to not only know its position but where it is going. But that is not all what GIS does. So GIS has some other information systems or other data layers that can be used for some kind of a commercial forecasting. For example, if you want to engage in mass marketing of products and services, the GIS then is widely available for personal computers and workstations that have large marketing databases, which can be searched in a content-based fashion using the graphical user interfaces, directed queries based on displayed map information. So that is why GIS becomes very useful. A relatively new area of the GIS is research, is that it's doing its part to solve some of the problems of the planet. Uh, and marine GIS is playing a very important role in the understanding of future environments and coastal communities. How is weather changing there? How is the climate change affecting the different parts of the earth? Whether there is any sea level rise, whether there is melting of glaciers, because sea level rise will impact the huge population centers around the world's coast, right? So this is what the GIS system is using. So it gets all this data from various resources, and then it is using it to analyze and study the impact of these systems that are affecting the earth as well. So of course our focus here will be on the marine GIS, but I want to make sure that you guys know that GIS is not only limited to its use in the marine ECDIS, but it can be used, it is an information systems. It has a information system where, so if you tomorrow, if you stop working in the marine industry and you go into another industry such as manufacturing, logistics, marketing, customer service, you might find that the GIS based application systems are being used there to store information, analyze that information, and then produce the required information based on the user's demand. So that is what I want you to understand before I go into the marine ECDIS. Now that we have understood what is an ECDIS and what is a GIS and how a GIS forms the basis of an ECDIS, let's talk about the marine GIS. The marine GIS actually is based on the marine geography. Now, marine geography has, of course, received a lot of attention, especially with the climate change happening, the glaciers melting, the level of oceans rising. Now, the other recent factors that has increased the exposure of marine geography has been the rising global environmental awareness and concerns, the increased pollution, the endangerment of marine fish populations, etc. All right, so there were many initiatives that were concerned with different facets of the marine GIS, usually occurring independently and often in ignorance of each other. Now, the domain of the marine, as opposed to the coastal GIS, is here defined as the deep open water and ice beyond the human side of the coast. So this will include the bays, the estuaries, the dunes, the coastal wetlands, and the similar. The distinction is made because marine and coastal GIS, both as application domains and as user communities, have until recent years they have developed fairly independent of each other. They are not the same. So marine applications of GIS has been more in the basic science, whereas coastal applications have encompassed both the basic and the applied science, as well as the policy and management as well. All right, so of course there is a lot of research being published. I don't want to go into all that research there, but there is this boundary between the marine GIS and the coastal GIS that you have to clearly understand. However, the boundaries are slowly dissipating and slowly being integrated. Now, the marine GIS is actually, of course, a growing field. It is a field that requires a mechanism for representing the great volumes of multi-dimensional data. Now, anyone who works with marine data is aware of the challenges faced when trying to represent the multidimensional data from a point of view of the marine research. Now, the data includes timestamp data, height of tide, variation, temporal data analysis, subsurface data, salinity, pressure, and how all those data affects the marine diversity or the marine biodiversity or the marine geography. Now, of course, marine sciences benefit immensely from GIS because these computer tools are designed to bring together all this spatial data from diverse sources into one single database so that they can be analyzed and overlapped to provide the information. So a lot of manipulation of maps, digital maps, and tables of data items are required. And all these data from oceanographic surveys, satellite images, seafloor mappings, biogeochemical studies, they are analyzed and modeled, and the interrelationships between these are studies to provide the required information to the mariner, or rather I would say the user. Regarding the coastal GIS, of course, it's applying GIS to the coast, which is an activity in which a number of frontiers and boundaries need to be considered. Now, you have to understand the nature of the coast system first. And secondly, the coast can be seen as a cultural and conceptual frontier, representing a transition zone between the known and the comparatively unknown. Then you also have to think about the line of the shore, which is often used as an administrative and jurisdictional division. All right, so some coast is of course part of the state, some coast is considered to be not part of any state but international boundaries, so on and so forth. And of course you have to understand the current limitations of the GIS science and the technology as well. Now, GIS in exploration and production is also plays a fundamental role in the integration of different databases or different types of data. So you take the geological data, geophysical, engineering, environmental, and production data. And all these data is then brought together in one common interface and provide support to the decision-making process. Now what you see on your screen is of course the modern bridge with electronic chart systems, in which all this data is now integrated, and it is known as integrated bridge systems. And I'm going to be talking about the integrated bridge systems as well later on in the slide. So the fundamental component of any GIS is the data. Now, because the electronic navigation charts are managed as a database, they are considered to be the form of the Geographical Information System. Now, some hydrographic offices initiate the developing of the electronic navigation charts from the early stages and proceeded to construct the Coastal Information Management System for environmental protection. Now, that has also led into the integration of the GIS for the modern ECDIS that you use. So the introduction of the modern mapping tools such as the GIS, or there are some other tools such as video plotters, raster charts, numerical maps, electronic chart systems, GPS, they have forced the hydrographic community to depart from the paper charts and develop the more modern or the digital spatial data where the products meet the user needs. Alright, and that is where the ECDIS came into play. The ECDIS actually replaced the traditional paper charts that were used for many years. Now, the relevance of ECDIS, of course, becomes very important now because it is a significant contributor to the safety of navigation. It prevents many groundings, pollution. Also, it demonstrates the immense capability that can be unleashed by the development of the GIS-based systems. And it also demonstrates the need for global cooperation at the government and government agency level, because the data has to be collected from various sources all over the world so that it can be integrated and provide the necessary information required to the mariner. It can not be based on only one area. All right, so therefore the integrated management systems or the bridge systems, and I'll talk about that as well as you go along, but benefits of ECDIS include efficient updating, route monitoring, situational awareness, route planning, safety alarms, voice recording, paper chart reduction systems. Fantastic. So this is what the benefits of ECDIS is. Now, many of the GIS applications are significant examples at the regional or local level. Now, let me give you an example here. Now, say there is an oil spill and there is an oil spill accident which has happened in a certain area. Now, you would need necessary information to help recover spilled oil, in this case of pollution. And that can be obtained using the GIS systems, because the dispersion of the spilled oil and the result of the drift reduction can be displayed superimposed one on top of the other and provided to the hydrographic officers, who can then pass on the information to the parties involved in the cleanup operations. So integration of data obtained from different systems can then be superimposed, layered in such a way that can be used for multiple purposes. Now, like I said before, that the GIS systems and the discussion of this in ECDIS is very important to understand how it all comes together towards the end when we talk about the integrated bridge management systems. Now, the human visual system has an enormous capacity for receiving and interpreting the data quickly and efficiently. When you look at data, your mind is so evolved, the brain is so sophisticated that it processes all the data quickly. However, the more intuitive the presentation, the more rapidly the data is interpreted, and that is what the GIS is trying to do. The GIS is trying to present the data in such a way that the multiple data can be processed quickly by the user and then used for the right information. Now, ECDIS and its accompanying electronic navigation charts are moving forward towards reality. The sea areas being covered by electronic navigation charts are being extended on a daily basis. The standardization process for two-dimensional electronic navigation charts is almost complete, and some of the navigators are even thinking about international standards for three-dimensional navigation charts. Now, one of the forms of marine application of GIS is the electronic chart and display and information system, which is the ECDIS. But this composed system is part of the management information system and the navigational information system, known as the INS or the IBS. Now, ECDIS is not the most integrated system on the navigational bridge. It is only an element of the integrated navigation system. The integrated navigation system is also sometimes called electronic charting and integrated navigation system, ECINS, which is a part of a fully integrated, more sophisticated integrated bridge systems, IBS. It can combine ECDIS with GPS, radars, RPAS, AIS, GMDSS, and other ships' inner systems, such as the ship's engine, the deck, cargo communication systems. All together, then it forms the integrated bridge systems. Now, as integrated navigation system is a composite navigation system, it performs mainly two tasks: collision avoidance, route monitoring, and track control. And it adds value to the mariner in terms of safety of navigation. The purpose of the integrated navigation system, or INS, is to enhance the safety of navigation by providing the integrated and augmented functions to avoid geographic, traffic, and environmental hazards. Basically, it brings together all the equipments present on the bridge so that the data can be integrated and presented in kind of a singular format to the mariner, who doesn't then have to look at many screens altogether. He can just look at one screen, or she can look at one screen and get the information that is required for safety of navigation. And that is why we spent a lot of time understanding what is GIS, because GIS is pretty much doing the same thing. It's a computer information system that brings together all the data and then tries to provide a user-friendly interpretation of it in the form of maps or charts or graphical data. So you can see here that the integrated management system has the word integrated in it. So integrity means the ability of the INS to provide the user with information within the specified accuracy in a timely, complete, and unambiguous manner, so that there are no doubts. There are alarms and indications provided as well within a specified time when the system should be used with caution, or maybe not used at all. Now the integrity monitoring, it is an internal function of the INS. The INS supports safety of navigation by evaluating all the inputs that it gets from all the different equipments. It combines them to provide the information, giving timely warnings of dangerous situations, system failures, degradation of the integrity of the information, so on and so forth. The INS presents correct, timely, and unambiguous information to the users. It takes into human factors into consideration. The workload is kept within the capacity of the marine officer who's keeping the watch on the bridge, so that the marine officer is not distracted from his main duties. He gets through a quick glance on the screen, he or she gets the information required. So the INS actually increases the safety of navigation by reducing the workload of the mariner, so that the mariner doesn't have to look at many screens, instead looks at one screen or a couple of screens and gets the information. It reduces the stress created by alarms of the multiple equipment. It has the equipments only, there is only one equipment that provides the alarms then. And then you can cross-check the information, you can monitor the systems and provide improved fallback and backup. Lastly, I would talk about the integrated bridge system, which is a combination of equipment and software using interconnected controls and displays to present a comprehensive suite of navigational information to the mariner. Alright, so the IBS generally consists of a dual ECDIS installation, one serving as a master and another as a backup. And route planning station. The IBS also comprises of dual radar and ARPA installation, DGPS positioning, AIS, a conning display with the presentation of information from the master ECDIS, then a GPS or some other speed measuring systems such as logs, Doppler logs, electronic magnetic logs, autopilot and gyro compass systems, and a fully integrated GMDSS functionality. All right, so some systems include full internal communications as well, so that will include monitoring fires, shipboard status alarms, machinery control. Depends on the systems. Of course, there are many systems available within the integrated bridge management system as well, and IBS is designed to centralize the functions of monitoring collision and grounding risks. It also automates the navigation and ship control. Alright, so of course different classification societies then have their own requirements and they approve the systems based on their own requirements. So you will have to study the requirements of the flag state under which your ship is sailing to understand what is considered to be an approved integrated management systems based on your flag state. Alright, so basically the system and its physical arrangement, it should enable the bridge team and the pilot to con the ship by verbal instructions from any position of the bridge while still having access to heading, rudder, angle, propeller, RPM, pitch indicator, and rate of turn information. So the system should support procedures and actions to address the failure modes and default to manual controls on failure of the automated ship control functions. It should be designed so that its operation minimizes distraction on the bridge, like I told you before, and it should not interfere with the vigilance of the bridge team and the pilot. The focus should be on handling the ship rather than operating the system and shutting down the alarms, resetting the alarms, stopping the alarms. Those kind of distractions should be kept at a minimum. So I think this is where I will end today's video on the ECDIS systems. It is pretty long already. I plan to make many videos on the ECDIS system so that your knowledge about this system is very holistic, it is complete, it is whole. I also thank the book ECDIS, an Information System or Operational Handbook by Adam Weintraub. And thank you for watching, guys. And you will see me with my next video on ECDIS soon. Bye for now.